Hello students, welcome back again with the same chapter, chemical equations and reactions. So in previous video we talked about the type of reactions and we have covered two reactions there. One is the combination and one is the decomposition, and the types of decomposition also we have discussed. So in this present video we'll discuss about another two types of reaction, that is the next is displacement. Third is displacement reaction. Okay, displacement reaction is that reaction in which a more reactive metal displaces a less reactive metal, or you can say that ions, they are replacing the other ions from the solution, or you can say that the movement of the ions are taking place. Okay, so displacement reaction is that reaction in which a more reactive metal displaces a less reactive metal from its salt solution. This is very important, that from its salt solution, otherwise it will not be able to displace. For example, let's consider the general reaction. Let's say A reacts with BC. Okay, A reacts with the compound BC. Now here A is more reactive. Okay, so BC is the compound, that is the salt solution. Now what is the product here? A is more reactive, so it means it can easily displace the metal B from its solution. So what gets formed? AC plus B. So this is the displacement. Suppose if I'll say that B is more reactive, A plus BC gives you, and I'm saying B is more reactive. Okay, then A will not be able to replace, A will not be able to displace B from its solution because A is less reactive, so here no reaction takes place. This is the meaning of the displacement reaction, that this takes place when a more reactive element displaces a less reactive element from its salt solution. Okay, or you can say that the movement of the ions are taking place. This I will show you how the movement of the ions. Okay, so let's take the particular example. Let's say zinc is reacting with H2SO4. Zinc is the metal, zinc granules will react. This is aqueous, gives you what? ZnSO4 plus, this is also aqueous, hydrogen will evolve. Okay, now the question is, you can say that here the hydrogen is not a metal, but it's a non-metal here. But when we'll see the series of a reactivity of metals, then you will find hydrogen is there. Here, there it is considered a standard metal with the help of which we are comparing. So there zinc is more reactive because metals are always more reactive. So zinc is more reactive than hydrogen. Fine. That's why it is able to displace hydrogen from its salt solution and making its own salt solution. Okay, and hydrogen is getting evolved. If I'll take any other example, let's say iron reacts with copper sulfate. Again, this is solid and this is aqueous, blue in color. Okay, this also we have discussed earlier in the characteristics of the reaction. So what you will find, iron here it is more reactive than copper. So it will displace. So FeSO4 gets formed, aqueous plus copper gets deposited. This is brown colored substance gets deposited, this is green in color. So this is about displacement reaction. So this always takes place whenever an element is more reactive than the other one, and then only it forms its own salt solution. Okay. So let's discuss more examples on the basis of the series. Now how will come to know that which metal is more reactive? This is also the question. By looking at the reactant we don't know, but we have to learn one series. There is a reactivity series, and this is that series where the elements are arranged in order of their reactivities, or you can say on the basis of their reactivities. Okay, so let's discuss the series. So the series is like reactivity series, arrangement of the metals in order of their decreasing reactivity. reactivity series of metals. This you have to learn. Okay, so first is at the top potassium is present, then sodium, then calcium, magnesium, aluminium, zinc, iron, tin, then comes hydrogen. Okay, sorry, after tin lead is there, then comes hydrogen, then copper, silver, gold and platinum. Okay, so this is the most reactive metal, most reactive. And as we are moving down, reactivity decreases. Okay, and these metals, they are, you can say, non-reactive or least reactive. So you can say that the metals which are present above hydrogen, here hydrogen is taken as the standard form, standard element. Above hydrogen they are reactive and below hydrogen they are not reactive or least reactive. Fine. And the metals, these metals, you can say they are moderately reactive. The series is given in the next third chapter, metals and non-metals. Okay, but here this is required, so that's why I am discussing here. Sodium is most reactive, these are least reactive or you can say non-reactive, and they are moderately reactive. Now you can compare. See, we have the example which we have discussed, iron and copper sulfate. So iron is more reactive, that's why it has displaced this. If we take the opposite, copper sulfate, this copper with the iron sulfate, then in that case reaction will not take place. So this is the reactivity series. Okay, now let's discuss more examples based on the series and we'll come to know that the particular reaction will take place or not. Okay, so this series you have to learn. So let's consider different examples. Zinc reacts with copper sulfate. Okay, gives you zinc sulfate plus copper. This is blue in color and this is white or colorless. White in color. Fine. Now in the series when you will find that zinc is more reactive than copper. Here zinc is more reactive than copper. That's why reaction is taking place. If I take the reverse of this, ZnSO4 plus copper. Okay, here zinc is more reactive than copper, so copper will not be able to displace zinc from its salt solution. So here no reaction. So in this way you are supposed to make the combination and you will come to know whether the particular reaction takes place or not. One more example I am taking. Let's take aluminium sulfate. Fine. And I am reacting with this magnesium. Okay, now aluminium is, here magnesium is more reactive. So it will be able to displace. So magnesium sulfate gets formed and aluminium will remain. You can balance the reaction here. 2Al. Three is 4 3s are 12, 4 3s are 12. Now it's balanced. Fine. So this is the reaction. And in all the types of chemical reaction, you are supposed to write the balanced chemical equation. Okay. So these are the particular combination. Fine. So let's start with the next part. Double displacement reaction. Again, very, very important. Double displacement. Fourth one is double displacement reaction. Now in displacement reaction, what happens? That the only one ion is getting exchanged. Now here what will happen? In double displacement reaction, as the name suggests, double. So both the ions, okay, both the ions of the solution will exchange their position and will form the products. For example, if I take barium chloride with sodium sulfate. Okay, so here we are supposed to take their aqueous solution. Okay, double displacement reaction always takes place with the aqueous solutions of the compound, and in their aqueous solution, because they are able to split into in the form of ions, so that's why aqueous solutions are required. In aqueous solution, they'll just exchange their ions and they will form the compound. Now how they will exchange their ions? See, can we write this? Ba2 positive, Cl minus. Fine. This also Na positive, SO4 2 minus. So valencies are required here. Now what will happen? Positive will go with the negative one and negative one will go with the positive one. So here formula making is required. Okay, you should know how to make the formulas. So barium will go with now sulfate, positive with the negative, and sodium will go with the chloride. So now the products are easy. So what are the products here? Barium sulfate plus NaCl, balancing NaC. In general, if I write, let's combine AB plus CD gives you what? See here, A positive, B negative, C positive and D negative. So A will go with D and C will go with B. So AD is the product and BC is the product. This is in general. Okay, so remember one thing, positive will always go with the negative one and negative one will always go with the positive one. Opposite charges, they just attract each other. So this is the double displacement reaction, that the reaction which takes place, or you can say the reaction in which the exchange of ions takes place in the aqueous solutions of the compounds. That is double displacement reaction. Now, double displacement reaction, it is of two types. So let's see the two types. One is the precipitation reaction and one is the neutralization. So let's see both the parts. Barium sulfate, here it is white precipitate. This is white precipitate. So let's consider the types of double displacement. So it is of two types, and in both the types aqueous solutions are required, but the compound will change. So first is your precipitation reaction, and the second one is neutralization reaction. Precipitation reactions are those reactions in which the exchange of ions takes place between the two aqueous solutions of the compound, like the example which we have discussed. Okay, that is the example of precipitation reaction. In this, precipitate gets formed, that is precipitate gets formed, or you can say insoluble product. Insoluble product is known as precipitate. Okay, so let's take the other example. If I'll say, let's add this PbSO4 reacts with Ki. Okay, so here if I write in terms of Pb2 positive, SO4 2 minus, K positive, I minus. This will go with this and this will go with this. So what are the products? PbI2, formula making, this must here, and potassium sulfate. So these are the products. So here PbI2 is the precipitate. Here in this case yellow precipitate. Color if you don't know then it's not a problem, but precipitate you should know that the precipitate of this substance gets formed. Okay, so this is the precipitation. Now let's come to the neutralization reaction. Neutralization reactions are those reactions in which aqueous solutions of acid and bases react. Okay, this will be again we will be studying in the second chapter. Okay, acid, bases and salts. So neutralization reactions are those, as the word is neutralization. So acid will neutralize base and base will neutralize the acid. Okay, so in neutralization reaction, this is the first part we have discussed. First part. Now second, if I say any acid reacts with base, it gives you salt plus water. For example, generally just take HCl plus NaOH. Okay, salt. Now again split product. You can write applying the same concept, exchange of ions. But here we always take aqueous solutions of the acids and bases. Remember this thing. And here aqueous solutions of the compounds. OH minus. Fine. Exchange of ions. What you will get? NaCl plus water. H plus and OH minus together they will form the water. This is salt, NaCl, we know that sodium chloride is a salt. Okay, so this is the example of neutralization and in all double displacement where the ions are getting exchanged between the two aqueous solutions. Let's discuss more example, one or more example of neutralization. Fine, neutralization. If I take any other acid, let's say nitric acid, reacts with potassium hydroxide. What are the products? Split HNO3, NO3 minus, K positive, OH minus. Water is always the product. Remember this thing because H plus will come from acid and OH minus will come from the base. This is the characteristic of acid and a base. So you will get potassium nitrate salt plus water. In this way you are supposed to write down the product. No need to mug up, no need to learn anything. In double displacement reaction you can easily write down the product on your own. Same in the case of displacement also. Okay, I hope it's clear to everyone. So the last reaction is left, that is oxidation reaction. So we'll discuss in the next video. Okay, till then thank you and have a nice day.